So yesterday, artificial intelligence basically just lived invisibly in the cloud. You download an update, your phone gets a little smarter, and you don't really think about the physical machinery making it happen.
Right, it's just happening somewhere else.
Yeah, exactly. But today,
Yeah.
it looks like that intelligence is literally packing its bags for orbit.
It's a massive physical relocation. The breaking news we're seeing from yesterday and today, May 6th and 7th, it just fundamentally changes the definition of what an AI company actually is.
Yeah, because Elon Musk just confirmed that xAI is officially dissolving. Like, as a standalone software company, it's gone.
Right, it's completely folding into SpaceX.
Exactly, under this brand new banner,
Yeah.
SpaceXAI. And the numbers here are staggering. We are looking at a combined entity valued at $1.25 trillion.
Which is just a massive valuation.
Yeah, that breaks down to SpaceX at $1 trillion and xAI at $250 billion. So for this deep dive, we've got a really fascinating stack of sources, leaked internal memos, highly detailed financial models, and some pretty heavy-duty aerospace engineering analyses.
And our objective here is to figure out the ultimate end game. Because we aren't just breaking down a normal corporate merger, We are looking at a literal physical blueprint to take the brain of artificial intelligence and just launch it into the vacuum of space.
Which is so wild. And if you're listening to this, you might think AI is just, a handy tool that drafts your emails or analyzes data on your laptop.
Sure.
But the physical reality of how that intelligence is powered is moving off-world. And that shift is going to rewrite the global economy, the architecture of the internet, and, well, the future of space exploration forever.
It's a leap from software engineering to planetary scale engineering.
Right. Okay, let's unpack this. Why does a company building artificial intelligence need to merge with a company that builds rockets?
Well, to understand the motivation, we really have to look at the primary bottleneck of modern technology right now, which is earthly physics.
Earthly physics.
Yeah. The frontier AI models being developed right now, the system's really pushing the boundaries of machine reasoning. They don't just run on a single computer. They rely on massive parallel processing.
Right.
We are talking about networking hundreds of thousands of advanced GPUs together, all running simultaneously at maximum capacity 2047 just to train the next iteration of the model.
And doing that requires power on a scale that our current infrastructure simply wasn't built to handle. We aren't talking about a few extra megawatts anymore. We're talking about gigawatt scale power draws.
Exactly. And a single gigawatt is roughly the equivalent of the power needed to run a medium-sized city.
Wow.
So when you try to plug a gigawatt-scale data center into a local terrestrial grid, you just run into insurmountable constraints. Take the Memphis Colossus cluster they've been expanding.
Right, the one in Tennessee.
Yeah, the energy draw there strains the surrounding national grid. But beyond just power, those chips generate an immense amount of heat. So you need millions of gallons of fresh water just for the cooling towers.
Which causes its own problems.
Right. You need massive tracts of land, and you face intense regulatory pushback from local communities who, understandably, don't want their resources drained by a massive server farm. Earth simply cannot sustain the resource demands of the AI future Musk is projecting.
So it's kind of like trying to train the next generation of super intelligent AI on Earth is like trying to run a massive, heavy manufacturing factory inside a tiny sealed greenhouse.
Oh, that's a great way to put it.
Yeah, eventually you run out of air, the grid acts like a bucket of AA batteries trying to power industrial machinery, and the trapped heat literally cooks you alive.
Yeah.
Moving to space basically shatters the glass of the greenhouse.
That analogy gets right to the core of the February 2nd memo that dropped during the initial acquisition. The memo essentially argues that to scale AI, you have to move it to a place where space and energy are functionally infinite.
Right.
Musk summed it up with the phrase, "It's always sunny in space."
Which is catchy. But wait, space is a vacuum. You can't just run an industrial fan if there's no air to blow around.
Yeah.
So how do you cool a gigawatt-level server farm without atmospheric air or millions of gallons of earthly water?
What's fascinating here is how you essentially trade one set of physics for another. That's the fundamental difference between convection and thermal radiation.
Okay, break that down for us.
So on Earth, we rely on convection. We use water or air to physically absorb heat and carry it away from the chips.
Right, like a fan blowing across a hot processor.
Exactly. But in space, because there is no air, convection is impossible. Instead, you have to use massive, specialized panels to capture the heat and radiate it as infrared energy directly out into the absolute zero of the void.
So deep space just serves as an infinite heat sink.
Yes. And if you solve the thermal radiation engineering and you collect unfiltered solar energy from arrays that never experience nighttime or cloudy weather, you drive the long-term marginal cost of running these massive AI models to near zero.
Wow. So the physics make sense. The universe provides the energy and the cooling. But, I mean, down here on Earth, somebody still has to pay for the rockets to actually haul the servers up there.
Right. Getting it there is the hard part.
Yeah, this whole vision requires a massive financial marriage to survive the upfront costs. Because xAI is incredibly capital intensive, right?
Oh, absolutely. It's a cash-burning machine. Developing frontier AI requires a process we can call capital to compute conversion.
Capital to compute.
Yeah. You are basically shoveling billions of dollars into a furnace to buy the hardware and the energy required to make the algorithm just marginally smarter. It is a severe cash burn.
And SpaceX has, like, the exact opposite financial profile right now, primarily because of Starlink.
Exactly. They have structural, recurring cash flow from millions of internet subscribers globally. Plus, they have the Starship heavy launch infrastructure ready to go.
Right, so the financial models in our sources outline how Starlink revenue basically offsets xAI's burn rate, while Starship serves as the literal delivery mechanism.
Yes, and by dissolving the xAI brand and folding it into SpaceXAI, they create this incredibly unified narrative right as we approach the heavily rumored June or July 2026 initial public offering.
Right, the IPO.
Yeah, so investors won't just be evaluating a rocket company or an internet provider. They are evaluating a $1.25 trillion off-world intelligence monopoly.
But wait, doesn't that just make xAI a massive parasite?
How do you mean?
Well, SpaceX spent 2 grueling decades clawing its way to profitability, right?
Huh.
Figuring out how to land rockets backward, building a satellite internet business from scratch. And now this cash-hungry AI supercomputer is just going to drain SpaceX's hard-earned profits to survive right before an IPO. That seems like a massive red flag for any potential investor.
It's a fair point, and honestly, several major Wall Street analyst reports flag that exact vulnerability.
Oh, really?
Yeah. The concern is that tethering a highly profitable launch business to an experimental AI venture could drag down the entire balance sheet.
Which makes sense.
It does, but the structural justification for the merger is the creation of a closed-loop ecosystem. If xAI remained a standalone company, it would be permanently dependent on venture capital funding and third-party data centers.
Okay, I see.
By bringing it in-house, xAI gets a dedicated launch provider at cost. And in return, SpaceX secures a proprietary superintelligence to run its future fleets without paying licensing fees to some outside vendor.
Ah, okay. That makes the 1.25 trillion valuation suddenly seem a lot more defensible. It's not just two companies sharing a bank account. It's a structural advantage that competitors basically cannot replicate.
Exactly. If we connect this to the bigger picture, it really mirrors the historical tech monopolies, but, on a cosmic scale.
Like who?
Think of Standard Oil in the early 20th century. They didn't just sell oil, they owned the raw materials, the refineries, the distribution pipelines, and the delivery trucks. Musk is doing exactly that, just in low Earth orbit.
Right, so pure software companies like OpenAI, Google, or Anthropic are suddenly in a very precarious position.
Very much so.
I mean, Google might have brilliant software engineers, but they're entirely dependent on terrestrial infrastructure. They have to rent servers from Amazon or Microsoft, they have to negotiate power permits with local governments, and they rely on public grids.
While Musk is building an empire where he owns the launch vehicles, the low Earth orbit communications network, the social media platform supplying the raw training data, which is X, and the intelligence itself.
It's incredible. And the integration flows in 2 distinct directions, right? Which just compounds the advantage.
Yes. First, you have AI going to space. The Grok models will be deployed to manage the logistics of the Starlink constellation.
Like to manage the satellites.
Exactly. When you have tens of thousands of satellites in orbit, you need real-time predictive AI to handle collision avoidance and dynamic bandwidth optimization. And that same AI will calculate orbital trajectories for autonomous Starship flights and manage logistics for deep space missions.
So the brain helps the physical rockets fly more efficiently.
Exactly. And conversely, you have space going to AI. The physical infrastructure feeds the brain.
Right, the data flywheel.
Yeah. Grok isn't just scraping text from websites anymore. It is training on exclusive real-time data from X, analyzing high-resolution global satellite imagery, and processing the telemetry of the entire Starlink network.
Wow.
That is a massive proprietary data set that literally no other AI company can access.
So it's one thing to build the world's smartest digital brain. It's another thing entirely when you also own the only roads to get to it, the delivery trucks that supply it, and the solar power plants that keep it alive.
Right. You can't just write a better algorithm in a garage in Silicon Valley to compete with this. You literally have to build your own space program.
Which is insane. But,
Hmm.
okay, this vertically integrated monopoly assumes the hardware actually survives the trip.
Right, which is a huge assumption.
Because the transition from a theoretical whiteboard to a physical data center in a vacuum introduces engineering hurdles that are, frankly, terrifying.
Mm.
Space is profoundly hostile to delicate electronics.
It's extremely hostile.
So let's look at those roadblocks. Because bolting a server rack to a satellite and calling it a data center sounds easy until you factor in the actual environment.
Right. And the primary technical hurdle here is radiation hardening.
Okay.
Modern AI processors, like the latest generation GPUs, rely on microscopic transistors packed incredibly close together. On Earth, our magnetic field and atmosphere shield these chips. But in orbit, cosmic rays and high-energy solar radiation just bombard the hardware.
And what happens when a cosmic ray hits a GPU?
A single high-energy particle striking a processor can cause what's called a bit flip. It literally changes a 0 to a 1 in the system's memory.
Oh, wow.
Yeah, and this can corrupt a trillion-parameter training run or just permanently fry the logic gates.
So you either have to redesign the chips themselves or wrap them in heavy shielding, which I'm guessing immediately increases the launch weight.
Exactly, which adds cost. And then there is the challenge of physical construction. You can't just fold up a gigawatt solar farm, shove it in a payload fairing, and pop it open in orbit like an umbrella. Building a gigawatt-class facility in zero gravity requires unprecedented in-orbit assembly. You were talking about autonomous robotics, welding, and connecting massive solar arrays and radiating panels while traveling at 17,000 miles per hour.
Which drives the economic hurdle to staggering heights.
Yeah.
The aerospace engineering analyses we looked at estimate that constructing a single 1 gigawatt orbital data center will cost approximately $42.4 billion.
Yeah, $42.4 billion.
For a single gigawatt.
Yeah.
That completely dwarfs the cost of building a massive facility in Memphis, even when you factor in buying the land and water rights.
Which means the entire economic viability of this SpaceXAI merger hinges on one specific metric: Starship's high-frequency reuse.
rocket launches.
Right. They have to target a launch cadence of 1 flight per hour to drop the cost of delivering payload to orbit below $100 per kilogram.
Wow.
If Starship encounters developmental delays or just fails to reach that turnaround speed, the math for orbital AI collapses entirely.
Okay, but I have to ask a very practical question about keeping this $42 billion investment alive.
Sure.
Down on Earth, if a GPU fails in the Memphis cluster, a technician literally walks down a climate-controlled aisle, unplugs the broken server, and swaps it out.
Yeah, it's pretty simple.
But if a server rack gets fried by a solar flare in low Earth orbit, what happens? Do we just end up with the world's most expensive piece of space junk floating above our heads? How do they solve the maintenance problem?
Well, the maintenance problem is perhaps the most heavily debated topic among the aerospace engineers we sourced. The prevailing strategy seems to be a combination of advanced robotic servicing vehicles and just extreme redundancy.
Redundancy, so just sending up more than they need.
Basically, yeah, you build the orbital clusters with so much excess capacity that you simply allow portions of the supercomputer to die over time, routing the workload around the dead sectors until a service mission can eventually replace the modules.
But our sources indicate the broader engineering community is pretty skeptical of doing this anytime soon, right?
Oh, highly skeptical. Independent experts estimate we are realistically 5 to 10 years away from demonstrating this kind of in-orbit assembly and autonomous maintenance at scale.
Right.
Musk's internal memos, however, operate on a timeline of 2 to 3 years to make space the lowest cost option for AI compute.
Which is quite a difference.
Yeah, and Wall Street largely views that aggressive timeline as a marketing tool, designed to build momentum for the IPO rather than a strict engineering deadline.
Still, despite the terrifying costs and the radiation risks, the internal documents show they are charging forward. Because when you look at the long-term master plan, beating Google or having a successful IPO isn't really the actual finish line.
No, not at all.
The goal is the structural evolution of the human species. So let's trace this timeline from the 2026 IPO all the way out to 2030 and beyond.
Okay, so the roadmap is staggered between terrestrial realities and cosmic ambitions. In the short term, looking at 2026 to 2027, the priority is securing capital. They will aggressively expand the Memphis Colossus cluster on the ground to push their Grok models past the trillion parameter mark. But concurrently, they plan to launch the first orbital validation satellites.
Essentially, these are proof-of-concept boxes sent up to see how quickly the radiation degrades the chips in a real-world scenario.
Correct. Then the medium-term phase, projected for 2028 to 2030, relies entirely on Starship hitting its reuse targets.
One flight per hour.
Exactly. Once that launch cadence is established, they plan to bring the first commercial orbital compute nodes online, generating actual revenue from off-world processing. And alongside that, they outline proof-of-concept testing for lunar manufacturing.
Okay, that's where this transitions from an aggressive tech strategy into what sounds like a sci-fi epic. Why on Earth, or I guess, why on the moon, manufacture AI hardware up there?
Well, the moon's gravity is only a fraction of Earth's, and there is no atmosphere. So once you establish the industrial capacity to mine lunar materials and manufacture the silicon and steel locally, getting the finished data centers into space requires vastly less energy. The internal memos actually detail the use of electromagnetic mass drivers.
Mass drivers. So basically giant electromagnetic catapult.
Effectively, yes. Because of the weak gravity, you can use a massive linear motor to accelerate the manufactured AI satellites along a track, literally catapulting them off the lunar surface and into deep space trajectories without needing any chemical rocket fuel.
That is just, wow. And the ultimate metric they are aiming for is launching 1 million tons of payload a year, right?
Yes. And by hitting that number, the memos calculate they can add 100 gigawatts of AI compute annually. And the phrase they use in the documents is that this is step one to reaching a Kardashev II civilization.
Which is a huge concept.
Yeah, the Kardashev scale is a fundamental concept in astrophysics for measuring a civilization's technological advancement based on its energy consumption. So a Type I civilization harnesses all the available energy of its home planet. A Type II civilization advances to the point where it captures and utilizes the entire energy output of its host star.
So SpaceXAI's vision isn't just about orbiting the Earth. They want to put 500 to 1,000 terawatts of AI satellites into orbit directly around the sun.
Yes. The internal documents refer to this culminating in the creation of a sentient sun.
A sentient sun?
A conscious, star-powered computational network. The idea is that this massive intelligence, drawing limitless energy from the sun, will act as the digital backbone required to support future human cities on Mars and coordinate complex deep space exploration.
I mean, using a term like sentient sun makes it sound like we're reading a sci-fi novel. But they are actively filing the telecommunications paperwork and welding the steel rockets in Texas to make the first steps happen today. It's just a staggering level of ambition.
It really is, and this raises an important question about the underlying philosophy driving all of this. SpaceXAI is the literal structural fusion of Elon Musk's two defining life goals.
How so?
Well, for decades, he has pursued the mission of making humanity a multiplanetary species with SpaceX. But simultaneously, he has warned about the risks of AI, advocating for the creation of an intelligence designed to understand the true nature of the universe with xAI.
Right.
By merging these entities, the philosophy becomes clear. You cannot achieve one without the other. You need the heavy lift rockets to physically build the megabrain, and you need the processing power of that megabrain to solve the lethal complexities of keeping humans alive on Mars.
We have covered an incredible amount of ground in space today. We started with the very real earthly constraints of power grids and water usage maxing out in the Memphis data centers.
Yeah.
We unpacked how the sheer financial gravity of a $1.25 trillion merger provides a structural cash flow to solve those earthly bottlenecks just in time for a historic IPO. We looked at the terrifying engineering challenges of fighting off cosmic radiation and building gigawatt solar arrays in a vacuum. And we ended up looking at a blueprint for using lunar catapults to build a conscious star.
It really forces us to acknowledge that the infrastructure of tomorrow is going to look nothing like the infrastructure of today. We are fundamentally redefining where computation happens, moving the limits of human achievement from the ground beneath our feet to the vacuum above our heads.
And it leaves you with something pretty wild to consider. When you look up at the night sky 10 years from now, you might not just be looking at burning gas and dead rocks. You might be looking at the physical hardware of a superintelligence, silently thinking, powered by the sun. What happens to humanity's relationship with the cosmos when the sky above us is quite literally awake?
That is a beautiful and deeply complex thought to leave on.
Thank you for joining us on this deep dive. Keep looking up, and we'll catch you next time.